Hello people, welcome to our channel CodersArts. In today's video, we'll be learning about static versus final keywords in Java. Let's get started with the final keyword. It is a modifier applicable to classes, methods, and variables. If we declare a parent class method as final, then we cannot override that method in the child class because its implementation is final. And if a class is declared as final, we cannot extend the functionality of that class. That is, we cannot create a child class for that class. Let's understand in simple terms. Final access modifier is applicable to classes, methods, and variables. So you can prefix it with class, method, and variable. Now, if we declare a parent class as final, parent class method as final, then we cannot override that method in the child class because its implementation is final. So here you have a class and you're trying to inherit it within the other class. Let's assume it this way. This is class P, parent class, and has got a method which is final. Okay. Then we have a class which is child class, which extends this parent class. Okay. Now, because child class is a subclass of parent class, you can override the methods you have within the parent class, right? So whatever methods you have in the parent class, they are applicable to be overridden in the child class. You can tweak its functionality, modify according to the new needs you have or you come across, right? But here in the parent class, if you declare the method to be final, then this concept is restricted. So you cannot override the method of a parent class in the child class if that method is final. So if any method is final in the parent class, that cannot be overridden in the child class. Why? Because its implementation is final. Whatever you've put inside this method, it is final. That cannot be modified, that you cannot provide a new implementation for that method. So its implementation becomes final. And the next point here is, if a class is declared as final, we cannot extend the functionality of that class. That is, we cannot create a child class for that class. Here in the previously what we came across was a class is not final, but the method inside the class was final. Even in that case, that method cannot be overridden in any of its child class. But now, what if the class becomes final? So if a class is final, then that class is not applicable for the concept of inheritance. You cannot inherit that class. You cannot extend it to any of its child classes. So the inheritance becomes invalid for the classes. Those are final. Every method present inside the final class is always final by default. So whatever methods, if a class is final, then all of its methods by default becomes final. But every variable present inside the final class need not be final. But the concept, this rule is not applicable for variables. Variables may be final, may not be final. But when it comes to methods, by default, all the methods are final within the final class. The main advantage of the final keyword is we can achieve security and we can provide a unique implementation. But the main disadvantage of the final keyword is we are missing key benefits of OOPS like inheritance and polymorphism. So here, if you see some of the advantages of final keyword, it helps you in achieving security and it also helps you in unique implementation. Like we said, we have seen in the demonstration of the previous points, if any method is prefixed as final, then you cannot change its implementation. You cannot change its functionality. So that implementation of that method becomes final. So unique implementation. So final keyword supports unique implementation. So that implementation becomes unique and cannot be tweaked by any of its child class. And also if you talk about achieving security, if you have a final class, then you cannot reuse that class with the help of inheritance. So that class is final and any of its methods cannot be reused by any of the other children classes. So thereby that class is secured. So through that we can achieve security. However, we've got some of the disadvantages, like we miss to use some of the key benefits of OOPS like inheritance, polymorphism. polymorphism is overriding. So overriding cannot happen, and also inheritance cannot happen if the class is final. Hence, if there are no specific requirements, then it is not recommended to use final keyword. Only if there is a necessity for security or for unique implementation, only then you can take up or pick up final keyword. But if in case if there are no such requirements, then it is not considered or recommended to make use of final keyword. We will look into it in more detail as we proceed further. So we have a code walkthrough. We will run a sample code snippet to help all of you understand more about the final keyword. So let's just switch to Eclipse and run the code. So here we have the final, wherein we have two classes, class P, which is a parent class, in which we've got two methods. Both the methods are non-final. If you see, we don't have the final keyword. So we will first see without final, and then we will see with final. And then we have the class C, which is a child class of P. Okay. So here again, we are overriding both of the methods. See, surname, its implementation is being overridden. And again, we are trying to override the surname that is present here. So here we have the surname. This method is being overridden here. So for now, it does not throw any error because the surname is not final method. So if you see, if you run it, it contributes to smooth execution. You won't see any error. But if you tweak it, if you make this surname method as final, and then try overriding this method, it does not. See, look, it does throw error. Let us save it and rerun the application to see what message compiler throws at us. Okay, it says error exists. Okay, so this is the error. It says class C overrides final method. So we cannot override final method, and you're attempting to override a final method, which is not possible. So therefore, this error is being thrown. It helps, it supports unique implementation of surname. That's why you're declaring it final, because you don't want at any cost its implementation to be changed. Therefore, you make it final. Also, we came across that if any class is final, then you cannot inherit it, right? So here, if we make P as final, and if you're trying to inherit it or trying inheritance, then you cannot do so because, again, the class is final, so it does not support the inheritance concept. So it does throw error. Here we have changed. You can override, but you cannot inherit this class because P is now final. So if it is not final, then again, the execution. We've seen is then we have seen it in this demonstration of the code snippet. So if the class is final, you cannot. If any method is final, then overriding does not happen. With this understanding, let's move back to the presentation. Understand the other concepts that we have in the video. Then we move on with static keyword. So we have come across final. Now let's understand what is static. The static keyword in Java is used for memory management. So the main purpose of static keyword is memory management. We can apply static keyword with variables, methods, blocks, and nested classes. So here we've come across a new term called blocks, which we will understand in detail. So we will look into each of its applications. So variable, if the variable is static, then you can also call that as class variable. And if the method is static, you can also call that as class method. And then it is applicable to blocks, it is applicable to nested classes. There's one more key point to note. The static keyword belongs to the class, then an instance of the class. So here, the static keyword does not belong to object, rather it belongs to class. So we will understand more in detail as we proceed further. Let's begin with static variable. The static variable can be used to refer for the common property of all objects, so which is not unique for each object. For example, the company name of employees, college names of students, etc. The static variable gets memory only once in the class area at the time of class loading. So where in what concepts can you make use of static variable is, you can make a variable to be static if that variable is not unique for each object. Rather, it is a common property. Suppose we have a college name. So if we have object students, then all the objects have similar college name. All the students study in the same college. So therefore, college name becomes a common property for all student objects. So in that case, you don't have to explicitly give a college name to each student. Rather, make one college name that becomes static, which can be accessed with all the objects, all student objects. We will look into more deeper dimensions with this image we have here. Look, this is a stack memory which contains two student objects, S1, S2. Now S1 points to its data in the heap memory, S2 points to its data in the heap memory. See, S2's ID is this and the name of the student is Aryan. And then S1's ID and the name of the student. Now the data is different because it's two different students. But if you see, the college name is applicable to both of the students because both of the students study in the same college, ITS. So if one property is common to all of the objects, then you can make that property as a static variable. So that the memory for this variable gets generated only once. By this, you can save memory. The main agenda here is memory management, saving of the memory. Add explicitly the variable, rather one variable applicable to all objects, thereby saving the memory. This covers the static variable. Let's move forward and see what else do we have. We have static method. A static method belongs to the class rather than the object of the class. A static method can be invoked without the need for creating an instance of the class. A static method can access static data member and can change the value of it. Let's look into a code snippet to understand better. Okay. So if you have a static method, as mentioned earlier, any static variable or static method, static class, it does not belong to object. It belongs to the class. And if you want to invoke or trigger a static method, you don't have to create the instance of the class. Rather, you can make use of a class name. And why you make use of static method? In order, if you want to tweak the static variable, then you can do it with the help of static method. That's how static method comes into picture. We'll understand by running through a code. So let's hop back to Eclipse and see a code for static. This is the code. Look, we have class student, and here you have the static variable college. And then we have the main method here, which creates the objects for student. And then we are also calling a static method called change. So therefore, we are not making use of the object here, rather we are making use of the class name because this is a static method. Now, if I run this code, you will understand in much better. Okay, see here, we created the object student S1 with these details, and we created the object S2 with these details. Now, if you look into student class, the college name initially was ITS, but we changed the name of the college to a different name. We gave a different name, and the name became BBDIT. And if we try printing the details of all students, you look, BBDIT becomes the college name. So the college name, the memory is allocated once. So if you change it, the change is applicable to all students. So it is because it belongs to class. It does not belong to individual object, right? This demonstrates the working of a static variable, how to access it, and how to call a static method. I hope this was clear. And let's move on and look further. Then we have a static block. So this might sound a little fresh concept, but let's understand. It is used to initialize the static data member. It is executed before the main method at the time of class loading. So this is an example for the same. See, if you want to declare a block, then this is the procedure. You just have to initiate it with static keyword, and whatever you need to do within that block, encode it with the flower braces and print it. So one thing you need to know is this static block gets executed before the main method. So before main method gets executed, the static block gets executed, okay? And why do we make use of it? So if you want some initializations to happen with respect to the static data member, then you can make use of the block. We will look into it as well. You go back to the same example in Eclipse. Let's just go back to the main method here. And if you remove these comments, this is how you declare a static variable. So before it enters to the main method, this statement would be executed. So if I save it and rerun it, see this statement gets executed, and then it creates the object of students and then prints the details of the students. All right, so this is the main agenda of static keywords, and why you can make use of it. You can make use of it if you want certain things to happen before you move on to the main method. And then we have the static class. The class in which the nested class is defined is known as the outer class. Unlike the top level classes, inner classes can be static. Non-static nested classes are also known as inner classes. So here you cannot define outer classes to be static, rather, but you can define inner classes as static. Okay. The concept for static class is only applicable for the inner classes. A static nested class may be instantiated without instantiating its outer class. Inner classes can access both static and non-static members of the outer class. A static class can access only the static members of the outer class. Okay. So if you have to access the inner class, then you need to create the object of the outer class. But if the inner class is static class, then instantiating the outer class is not necessary. So this is one advantage. And the inner classes can have access to both the static and non-static members. But if the inner class is a static class, then it can only access the static members of the outer class. So this is how static classes work. So this brings us to the end of the video. Hope the video was useful. If you find this video informative, then please do like, share, and subscribe to our channel. See you in the next video.